CCNA3 is mostly mostly about routers. It's mostly about routers. So we have 14 chapters. 14 chapters. Chapter 1. So for CCNA3, 14 chapters, and you'll be doing cybersecurity with Mr. Tom and Mr. Cassius. And there, how many chapters you have? You have 28 chapters. So if we don't start now, you'll end up finishing in January or February next year. That is impossible because latest week 1 of December, everything is closed. Latest week 1 December, everything is closed. So let's start with CCNA3. CCNA3, we have how many chapters? We have 14 chapters. It's mostly about routers. So we'll do OSPF. We did see that a router is a device that knows route or knows destinations. We have 2 ways to populate that routing table. We can add manually a route or a network. We call it static route. And we can also, a router can get automatic recorded networks via dynamic routing protocols. Please mute yourself. Who is making noise there? Please, all of you, mute yourself, please. Yeah, so we'll do OSPF. After that, we'll do a bit of network security. A bit of voice over IP, and network management. So all these things are theory. It's similar to CCNA, what you're doing with Mr. Tom, DevNet. It's a bit similar to DevNet. So let's jump in. We don't have too much time, so let's jump in now. So today we'll start with chapter 1 and chapter 2. We have the same thing. Chapter 1 is a theory. Chapter 2 is the configurations. So we'll combine both. We do a bit today, a bit tomorrow, and a bit Monday, and we are done for chapter 1 and chapter 2, so that you'll be free now to do labs with Mr. Cassius. So we did see that a router has a routing table, and if you have a router, if I open which one, this one, for example, if I open this guy, I tap enable, show IP route, you could see that the router has a list of networks, 10.0. So this is the topology where everything here is 10.0. Between the 2 routers is 20.0. The other side is 30.0. So if I take router 1, because this network is directly connected via G001, it will show up in the routing table. This one, 20.0, is also directly connected. It will show up in the 10.0 is directly connected. 20.0 is also directly connected. But 30.0, that is a remote network, is not directly connected. Sorry. So we either add manually, like we did for static route, or automatically. What automatically means, these 2 routers will talk to each other, and we're going to exchange database. Router 1 will say, hey, router 2, hello. I have router, I know networks A, B, C. What about you? Router 2 will say, hi, router 1, my name is router 2. Me too, I have a network D, E, F. And we're going to agree we say, okay, you know what? Let us exchange. So me, I'll send you don't router 2 share to router 1 what router 1 doesn't have, so that we have the same routing table to exchange. So remote network 30.0 is not in R1. We need to add it. We have two ways: static route, IP route to remote network, or automatically or dynamically via a dynamic routing table. So I did that already. So you'll see 30.0 is now in router 1. How? Via O. What O is, you think O is OSPF. It's a dynamic routing table. It will automatically add remote network in routing table. But you need to configure first. So now, what is OSPF? Let's check again. So OSPF, you see here, is a dynamic routing table. We have two groups: exterior gateway protocol. It's mostly for ISP, internet service providers. And they use Path Vector Routing Protocol, BGP. This one is a CCNP. If next year you do CCNP, you'll study this one a lot. It's for internet service provider. They use it, it's for big companies. For normal companies, we use interior gateway protocols. We use interior gateway protocols. And inside, we have also three groups. Eastern Vector that we are no longer using in the old days, yes. We also have link state routing protocol we mostly use, especially OSPF. EIGRP is combining distant vector and link state, and it's mostly for Cisco. So the most dynamic routing protocol we most use today is OSPF. We'll see how to configure. Now that you know the definition of OSPF, the definition of a dynamic routing protocol, how to configure. So to configure, it's simple. We have two ways we can use. For student who log on late, we are doing chapter 1 and 2. It's the same. Chapter 1 is OSPF concept, the theory. Chapter 2 is the configuration. So it's the same. So we combine them. We'll do a bit today, a bit tomorrow, and we finish on Monday. So we have two ways to configure OSPF. We can use the network command or the interface. What does it mean? How to configure OSPF? You can use the network command. You go to the router, to the global config mode. You tap router OSPF and the process ID. Then you add all the remote networks. This is how you configure. After that, everything will run automatically. So you go to global config mode, router OSPF, process ID, and the remote network. Be careful now. When you add the remote network, this time, it's recording. It's recording. 1 second. It's recording. Okay, it's recording. Now, be careful here. When you add a network, you add a remote network, then we have something, this time, it's not the subnet mask. It is called the wildcard mask. What is wildcard mask? Wildcard, I think it's one word, eh? Wildcard mask is the opposite of subnet mask. A wildcard mask is the opposite of subnet mask. example of subnet mask. And let me allow someone in who want to join. I cannot see. I'll show you here. Example of subnet mask. For example, if I say 255.255.255.25 .0, the wildcard mask will be. Let me put this one in one place here. The wildcard mask will be 255, 255, 255, 255 minus the subnet mask. Then you'll get what? The wildcard mask. In fact, let me remove this one here and put it somewhere else. I put it here. Yeah. So we say that the wildcard mask is the opposite of the subnet mask. So if you have this subnet mask, the wildcard mask will be. Then how do you do that? You do 255, 255, 255 minus the subnet mask. Then you do 255 minus 255, it will be 0. 255 minus 255 is 0. 255 minus 255 is 0. Then 255 minus 0 is 255. See? So this is what we call the wildcard mask. Let me copy this and put down here. One sec. Yeah. And I paste somewhere. What is it? I can put it down here. Yeah. So this is what we call the wildcard mask. So the wildcard mask is the opposite of the subnet mask. Example of subnet mask, 255.0. The wildcard mask will be, you do all 255s minus the subnet mask. Then you see 0.0.0.255 is a wildcard mask. So be careful when you configure the OSPF router OSPF, the process ID, any number, it will be given to you in the question. Network, the remote network, wildcard mask area 0. You can add another one, network, remote network, not the subnet mask, but the wildcard mask area 0 and so forth. So this is an example of configuring OSPF using the network command. You'll do a lot with Mr. Conscience. So if I go to my route, if I go in my router, because here I did configure OSPF already, I tap enable, show run. You see here, router OSPF 10, and I did add my remote networks. So what did I do? I'm here. This is a network directly connected, a network between the two routers, a remote network. So I will add each of them in. So to do so, you see, router OSPF process ID 10, network with dot 10, with dot 20, with dot 30, and be careful of the wildcard mask. If you say /24 to factor, then you know. It's not always like that. It depends on the value of your subnet. Then you do also. This is the first way of configuring OSPF. We have a second way using the interface. What does it mean? You go to the interface that is participating in OSPF. So interface gig. What does it mean? I have this router, and the interface G00 is connected to another router. G001 is connected to a LAN. So the interface that is connected to a LAN is not participating in OSPF process. Why? Because OSPF is router to router. We need to talk router to router, not router to switch. So this interface G001 that is talking to a switch, this one, we'll call it a passive interface. Passive interface. It means it's not participating in the OSPF process where we talk to each other, we exchange messages. You see, passive interface. And this is how we configure. So in your lab, we're going to, you will also do that. So the passive interface is not participating in OSPF process. It's the interface facing the LAN. But the other interface that is participating in OSPF process, meaning that is connected to another router, then you can activate OSPF. So you go to that interface that is connected to another router, then you tap IP OSPF with process ID, area 0. This is how you do. If you had another interface that is connected to another router, you go to that interface, IP OSPF 10 area 0. So these are the two ways of configuring OSPF. So 1 minute, check that again, and we continue. Okay. Now that we know how OSPF is configured, before we even start configuring OSPF, these two routers need to communicate. We need to greet each other. We need to be neighbors before we start exchanging database or the content of the routing table we share with the other one. We need to communicate, to talk to each other. We need to be neighbors. So for that, we have a lot of theory around that we'll skip, but for you, you must read. The only way, the big picture is the exchange messages. You don't need to memorize. So with OSPF, you have a lot of theory around hello packets. We're going to greet each other. So when we greet each other, to make sure that we are still alive, there is something called the hello time. I'm going to show you. Yeah, so today it's only some theory. Tomorrow we will do a bit of the hello interval to make sure that we are still connected, up and running. For them to communicate, we're going to greet each other. So router 1, the default hello is 10 seconds. router 1 will greet router 2, and it's going to wait. Within 10 seconds, router 2 should reply, "Hi, router 1, I'm still alive," and so forth. So if router 1 greets router 2, and after 40 seconds, router 2 doesn't reply, it means router 2 is down. I cannot waste my time by exchanging messages with them. So the default hello time is 10 seconds. The default dead time is 4 times the hello time. So for example, here, I'm on router 1. You go to interface facing router 2. You can configure yourself as an IT engineer. IP OSPF hello interval 5. It means every 5 seconds we need to greet each other to make sure that we are still connected. You can also set up the dead interval. Dead interval is always 4 times the hello interval. So with OSPF, there are a lot of things that we're going to exchange hello to make sure that we are still active and connected, database list of networks we know, and so that we can exchange and other stuff. So you don't need to memorize, just to understand the process, that's all, and how to configure. Yeah, so we need to be neighbors first. So we're going to keep track of neighbors table, like routing table, who are my neighbors, so that we can exchange stuff, and also database stuff. The most important is this. So you can tap show IP OSPF neighbor or show IP OSPF database. So listen, and we continue. Yeah, so these are some information, OSPF messages that we exchange to make sure that everything is running smoothly, especially the. So let's check show IP OSPF neighbor. I made a config before. I'll check now. Show IP OSPF question mark. So when you tap show IP OSPF, you can see show IPF database, show IPF interface, show IB neighbors. So for us, we're going to use neighbors. Press enter. Now you can see that I have a neighbor. And we have full. Full means what? We have full agency. We are neighbors. We did communicate. We did agree. We are friends. We are friends now. So we are, and we trust each other. We can start exchanging information. We'll see later what is DR. When we have many routers interconnected, we need to elect the big boss that will grab information and share to others. The main router of a big boss will call DR, designated router. We'll see how it works. Then the second one, the backup will be BDR, backup designated router. So we'll get there. For now, we do step by step. So these are some kind of information. These guys we communicate with. Okay, the system, how it works. Okay, you don't need to just. So we are a lot of. I think we have some videos. PSPF version 3 is for IPv6. you'll see sometimes OSPF version 2 for IPv4. And we have something also called areas. So for us, we'll do single area. It means all the routers will be in one box, for example, if I can say so. So we have single area OSPF. And we can also get a multi-area OSPF. This one will be for CCNP. In the old days, CCNA, we used to do both. But Cisco decided to keep single area for CCNA, multi-area for CCNP. So single area, this is how it is. And multi-area, we have the main one, the backbone, area 0, area 1, area 2. Then we are all connected to the main area. So yeah, so today it's only some theory, and with OSPF version 3, it will be same thing like OSPF version 2, but focusing on IPv6. Yeah, so to make your life easier, Cisco decided to group everything in one video. We do some demo, we explain more. Please check that video. OSPF packet. So when we are busy greeting, what is inside and blah, 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 all these things. So just focus on the video, we explain all this stuff. OSPF operation, also some videos. Yeah, it's all some theory, just watch the video, it's fine. And in case you have a lot of routers interconnected, you need to elect the big boss called VDR that will grab all main information, then share to others. VDR. How VDR is elected? We have election. The election is in chapter 2. Okay, so let's stop here for today. So for today, what you should know is what for today, yeah, today what you should know is the definition of a routing table is a list of networks a router knows about. You can add this route manually, we call it static route, or they can be there automatically via dynamic routing protocol. In dynamic routing protocols, we have two groups, exterior gateway protocols, mainly for ISPs, internet service providers. And for normal companies, we call it interior gateway protocols. And the main one is OSPF. How to configure? So OSPF is a protocol or a system that will automatically add remote network in a router. But before that, these two routers, they need to agree to know each other. Hello, this is router 1, router 2. Router 1 will send message to router 2. Hello, router 2. My name is router 1. Are you free for us to become neighbors so that we can exchange information? We can share our networks. If I have some network you don't have, I'll send them to you. And you too, if you have some network I don't have, you share us to from agencies. So we're going to talk. We have hello messages and a lot of stuff. Just check the videos, it's fine. So after now we are friends, we are neighbors. Now you need to configure, activate, it's finished. Anything else, we'll talk to each other to update anything. So you can comment. Router OSPF 10, the process ID, network, the remote network wildcard mask. Be careful of wildcard mask. Wildcard mask, oh sorry, let me fix one. Okay, what is it? Wildcard mask, let me fix one for all. Wildcard mask is the opposite of subnet mask. remove this guy. Yeah, so wildcard mask is the opposite of subnet mask. And this is an example here. If you have this subnet mask, how to find the wildcard, we do all 255s minus the subnet mask. 255 minus 255, 0, 0, 0, and this is the wildcard mask. Yeah, so you add network, remote network, wildcard mask, area 0. Or to configure OSPF, you can use the interface. You go to interface that is connected to another router, not a switch. Then you tap interface, you go to that interface, IP OSPF, process ID, area 0. Yeah, so that's all for today for now. Tomorrow, we'll do chapter 2. Then we'll do some configuration. In chapter 2, we'll see each router needs an ID because we're going to use that to elect VDR, the designated router. There is a process for that. We will need that ID to elect the router, the designated router. I want quickly to show you an example. Yeah, for example, here, why we need a router ID. For example, router 1, this is router ID. So we'll see what is the router ID, how to configure them. A router ID 1, router 2, 2, 2, 2, router 3. When you have such topology, we need one that will be the manager. It will be based on the highest router ID. So tomorrow we'll check what is the router ID, how to configure, why we need it is to elect this. So tomorrow also what we'll do, what is my file? Upload here. So we'll see what is the router ID, how to configure, what is the passive interface, how to configure, what is a loopback address, how to configure. And when you have methods like what we did, you need to elect DR, backup DR, and we'll check that. We also check how to modify OSPF. We can modify priority and other stuff. The core. So tomorrow we'll do that. Then we did a wrap up. We did a quick revision. I do some demo. Then next week Tuesday, you're good to go with Mr. Cassius to do some labs. So you have a lot of labs for that. 1, 2, 3, 4, 5, 6, 7. You see. After we are done with chapter 1, chapter 2, then you're ready to do all of these. Okay, let's stop here for today. Any questions before we close?
Sorry, sir, you said tomorrow we're gonna do chapter 2.
Yes, tomorrow
So,
we do
so
chapter 2.
are we done with
Chapter
chapter
1.
1? Is that all for chapter 1?
Yes, chapter 1 is the theory. Check here. Chapter 1 is concept. Let me go up. Single area concept. It means it's let's say some definitions. Some definition. What is OSPF? How it works? What are the messages we exchange? What is this? What is that? What is that? That's why we did today. Now, for chapter 2, it will be the configuration. Now that you know the theory, how to it the same thing. Then Monday, we combine again, we do revision, chapter 1, chapter 2, and we also do some demo. Any other questions? Okay, if no questions, tomorrow we continue. Before we start, feel free to ask
Sorry,
questions
sir.
if yes, question, yes.
Yeah, what about the exam?
Yes, the exam for now, we put it on hold until we are free to go to CPUT.
Okay.
Yeah, because yeah, we cannot decide. No one knows. When everything is calm and safe, then we go.
Okay. Thank you.
Okay, pleasure. So also remember, for those who log on late, CCNA3 we have 14 chapters. CCNA4 that you'll be doing with Mr. Cassius and Mr. Tom, because we are the one doing cybersecurity. We have 28 chapters. You'll get 28 chapters. And you need to finish all of them end of November. So please study. Don't delay stuff. If CPUT is not, student not tracking, instead of sitting there doing nothing, let's study. Let's study. If not, you'll end up next year, March 2026. But officially, we close end of February, November, latest week 1 of December. Because the academy must submit all your results to CPUT to double check everything and start processing your certificate for graduation next year. Okay, so it's recorded. If you want to check the recording, you can also check in your NetAccount. NetAccount has a problem. They put too much information and sometimes it's confusing students. That's why when we teach, we give you what is the most important, what you need to focus on. Like today, you should know what is the definition of dynamic routing protocol, what is OSPF, what are the 2 ways to configure OSPF. You can use the network command wildcard mask, or you can use the interface command. Then tomorrow continue with router ID. Other thing, when the 2 routers, we need to communicate to each other. We need to exchange messages. Cisco put 2 videos to make things easier. It's sometimes confusing. That's why we put with videos. You can watch them many times. It's only to greet, hello, I'm router 1. Who are you? I'm router 2. Can we be neighbors to exchange our information? Yes. So always communication, we call it OSPF messages. You have minutes after. But in a nutshell, it's that finished. Anything else, how to make the configuration and how to do the troubleshooting. Last question, any other question before we close? Okay, then we can stop for today. Please, when we are done like that, go to your NetAccount, start reading a bit while it's still fresh before the other teacher